see as well, I think. Thank you very much. So I'm Paola Valbonesi from Padova University. Welcome everyone to this online session on energy poverty. I'm very pleased to chair the session with the 4 papers. And we can start with the first paper. But before to start, let me just recall the rules. Every presenter will have about 20 minutes for the presentation, and then we will have 5 minutes for question and discussion. And if at the end of all the session we will have more time, we can open a sort of enlarge this discussion about the topic and the papers we had in the session. The 4 papers, maybe it is not the case I read the title, but I think we can start with the first one, which is on empirical investigation on energy poverty in Japan. Amin, the floor is yours. And let me check who are the other presenter. Is Enrico, are you presenting? Yes. Yes. So Benedikt, are you presenting as well? Okay. Yeah. And there should be another one. No? No other presenter among in the room? Okay, so let's go for Amin and then Enrico and finally Benedikt. Is it okay for you? Okay, so let's start, Amin. Do you mind to have a question during your presentation, or do you prefer to have at the very end?
Either is fine. I don't mind. Yeah, just feel free.
Okay, I would suggest that if you have clarification question, please do immediately. While if you have a question to discuss, I would suggest to have at the end of the presentation. Okay. Sure. Okay, Amin, the floor is yours. 20 minutes.
Just to mention, as Enrico also wrote right now in the comments, I think Pooja is also presenting. So there are 4 presenters today.
Okay, very good.
So let me get my...
So Pooja will be the last one, okay?
Okay. Okay, so can you see my slides and also hear me?
Yep. Go ahead.
Can you hear me? Sorry, I can't hear you.
Yes, yes. I can see and I can hear you.
I can hear you as well.
I lost your sound just a second. Can you hear me now?
Yes.
Yes.
Okay. Yes. It's fine.
Slides again. I lost your voice.
We can hear you and we can see the slide.
Yes, just 1 second because I lost your sound.
Good.
Okay, great. I can hear you now. Okay. So a very good morning or good afternoon or good evening from where you are. I heard you're from 7 a.m. over there, so I didn't know it's this early. I hope you had enough sleep. But it's 2 p.m. here in Tokyo. However, we also had earthquakes in the middle of the night, so
wow.
I'm also sleep deprived. But anyways, yeah, let's get into the topic. Well, my name is Amin Nazarahari, and I am from Tokyo Institute of Technology. I'm a PhD fellow, and I will be presenting to you the empirical investigation of energy poverty in Japan, the comparison of households in Tokyo and Behrooz City, and the site of the Behrooz City was in collaboration with Ritsumeikan Asia Pacific University. So here's a table of contents for today. Well, first I'll give you the introduction and literature review and research questions and focus. Then I will tell you about the methodology of our study, which we conducted original surveys for this specific study, and results and conclusion. And if you have time, we'll get into the work in progress that we're doing right now. Okay, so Well, first, I think we can all agree that energy is a daily necessity in all across the globe, and it's basically what's running our lives and also the economy. Between 1990 and 2014, the world economy nearly doubled, while energy consumption increased by 58.9%. And it is expected to increase by 50% between 2018 and 2050. And studies have also shown that there is a bidirectional causal relationship between energy consumption and economic growth. So with the rate that we're seeing, we're expecting the economy to also improve as well. However, meanwhile, there's still 940 million people, or 13% of the globe, which lack access to electricity or energy. And that is almost 1 in 7 people that have no access to electricity. Meanwhile, there's an imbalance of energy consumption and economic prosperity across the world, and there's the difference between the developed countries and developing countries, where the developed countries are getting more benefits. However, there's also the global intermittency in energy costs based on whether it is geopolitical issues, the geographical, technical, so many issues, and at the side, there's the climate change issue and greenhouse gas emissions, which beg for introducing or expanding renewable energies and new energy technologies. However, we saw that the costs of the ones that has to be borne by the households rise in long term due to things such as the fit rates and etc. So while all of these are ongoing, there's the energy poverty or the fuel poverty issue, which could be defined as the inability to possess or afford modern energy services. And the case is slightly different between developing countries and developed countries, whereas in the developing countries is more the issue of accessibility and no access to the energy or electricity. Whereas in the case of developed countries, the case is more affordability oriented. And as we are focusing on Japan, this is scope for study. You can hear whale talking if you, uh, anyways. So yeah, it is, our study is focused in Japan, so the affordability aspect of energy poverty is in study here. So in the case of Japan, the studies have started quite late, since 2016. And once we compare this to Europe or the England, where it started from 1970s, it is quite late, even though the studies right now have proved energy poverty to be an issue in Japan, and there's less than a dozen literature on this energy poverty and a few scholars only working on this. And one thing that we need to mention here is that the data is the National Survey of Family and Income Expenditure from the Ministry of Internal Affairs and Communications of Japan. And most of the studies basically focus on this data. Meanwhile, there's the indicator aspect of this, which is the 10% indicator, which is mostly used in the case of Japan. For those who might not be familiar with, is basically if your energy expenditure surpasses your income by 10%, this is considered as the case of energy poverty. So this is what has been used as the indicator mostly in Japan. So I'll explain to you later about what we are focusing on and why we are doing so. So the majority of the studies, as we mentioned, have focused on the National Survey of Family Income and Expenditure. However, they don't focus on the standards and qualitative data inside the households. Meanwhile, studies mostly focus on the vulnerable households, such as the parents, single parents, or those who got divorced, and aged, single, or couple elderly households, and etc. While there's no study of college students in Japan, even though they've been proved to be vulnerable to energy poverty elsewhere. And we saw that it is maybe required to assess the college students' case in Japan versus the ordinary households. But there was, as we mentioned, there was no data on the college students in Japan. So we thought we have to conduct original surveys for this study in order to get the data to assess this. So we broke down our study into 4 research questions, which the first and second is whether energy poverty is an existing issue in Japan, and if so, to what extent, and which households are most vulnerable in Japan. We're going to explain this based on the existing literature and the original findings of the survey. And then whether there's the reconsideration of vulnerables needed in Japan, and why energy poverty could be so-called as a hidden risk in Japan. This is what we are going to explain based on our original findings. As for the methodology, we conducted the surveys between December 2018 and January 2020. And we estimated the energy poverty based on the 10% indicator. So that was the coefficient that we used. And we conducted some statistical analysis, such as regression, standard deviation comparisons, the students' t-test and chi-square test, which we'll show you later on. But why was actually the national survey results not enough, and we had to conduct our original surveys? Well, there are some strengths of the national survey, such as the large number of samples and the reliability of it, and the complete responses, which is quite necessary in the case of energy poverty, because the issue of income and stating income is a quite sensitive topic, especially here in Japan. So most of the people avoid answering this, and if you don't have the income, it's very difficult to assess energy poverty based, especially on the 10% indicator. The breakdown within category, for example, the single households or the couple households was good, but however, the weakness is that the categorical limitation prevents us from doing this study. For example, there's no data, as we mentioned, on the college students, and it is irregular and conducted every 5 years. The last was in 2014, and most of the 2019 data up to now has been published, but no analysis of the data has been done in this case. And the lack of in-depth energy-oriented actions and behaviors and etc. was another weakness of the national survey. For this, we conducted our original surveys, and it was broken down into 4 categories: the demographics, energy carriers, consumption pattern, and the energy-oriented actions and behaviors. So what we did for this was we focused on these 2 for this study. The survey was quite long, 4 pages and 33 questions, so partial amount of the results were used for basically answering the 4 questions that we mentioned before. So in total, we collected around 724 households data in 2 cities of Tokyo and Behrooz. So the Tokyo is more the rich and the metropolitan aspect of the study, and Behrooz is more rural and aged, and the lower paying jobs or pension side of the story, to see whether there is a difference in between these 2. And the ordinary and student side of this was also collected separately in order to compare. So for the results, first, the existing literature, which was published in 2016 for the first time, proved that energy poverty was an existing issue in Japan at 4.7% since 2004. And it constantly increased until 2013 by 8.4%. And from 2014 to 2016, there was a slight decrease. And the rebound again happened since 2016. And with the current COVID conditions, we are currently working on and expecting for it to have increased for the households. And our current study estimated a 13.2% for 2020 in Japan. And once we break this down into two areas that we mentioned before, it is at a lower level in Tokyo at 10.6% and higher in Beppu 15.7%. And once we compare them to the existing data of 2015, the Kanto region, which includes Tokyo itself, was at lower level at this time and has seen an increase, but the increase was more apparent for the case of Kyushu, which also includes Beppu inside at 12.7% to 15.7%. On the other hand, the existing studies show that lower income deciles surpass energy poverty threshold by higher degrees. And basically, the higher income deciles it goes, the lower energy poverty ratio becomes. And based on our findings, we could also confirm this. First, we saw that basically the lower household income is, the higher energy poverty rate pushes, and vice versa. And on the other hand, also the first income decile surpassed this 10% severely, up to nearly 30%. But basically, the higher income deciles go, the lower and the less the the higher income deciles go, the less the energy poverty rate goes as well. On the other hand, the existing literature showed that highest rate of energy poverty was observed for households above 65 years old, and followed by 20 to 30 years age group, and the lowest was seen for 30 to 65, which is basically the ones that have families and high-paying jobs, and etc. Our study also partly proved this by saying basically that there's a trend line in higher the age goes, the higher the energy poverty rate goes, and the most was seen for 60 years above, which is the elderly group that was mentioned also before. And then we basically conducted students' t-test to determine the statistical significance between two sets of data of normal residents versus the students at an alpha of 0.05. And for the case of Beppu ordinary households versus the student households, we saw a p-value of 0.013, and same for Tokyo ordinary households and student households, where the p-value was lower than the alpha at 0.003. So by this, we rejected the null hypothesis of there's no difference between these two categories, and accepted the alternative, which was the there's a significant difference between students and the ordinary households inside the city. And moreover, we also compared the standard deviations and also the mean energy poverty rate inside the city, and in comparison to the residents and students. So basically, the energy expenditure to income ratio for Beppu residents was nearly 5%, and it is within one standard deviation away from the mean value. However, for the case of Tokyo residents, this is it takes much longer, as the mean value is lower and the standard deviation is also smaller. So within two standard deviations away from this mean value. On the other hand, for the students' case, both of them, the mean was already high by itself. So students would reach the threshold with less than half of the standard deviation. So this shows that students are more vulnerable or on the verge of becoming energy poor in case of any problems. Then there is the fact that why do we basically call it sort of a hidden threat, is that we asked the respondents the reasons to reduce the domestic energy consumption, if any, and the actions they take to curb domestic energy consumption. Well, for the first part is that for basically both students and non-students, 1/3 mentioned that the affordability was the reason why they would reduce the energy consumption, and climate change and emissions was at higher significance for non-students. However, there were some other factors that we highlighted for this case, which was waste minimization. So they thought it would go to waste because of saving resources in Japan, which is quite limited. Or in the case of Beppu, they have access to hot springs. So instead of taking showers or using hot water inside the house, they would have this natural source of using this hot water. So they would avoid using energy inside the household and kind of outsource this. On the other hand, there was the actions they would take to curb domestic energy consumption. The thing here that is of most significance is nearly half of the students mentioned that they would go to a restaurant or a cafe or a library or stay at the laboratories in order to reduce the domestic energy that they need to use. So that means, for example, they would have free energy outside, or they would pay very limited amount of money for a service or a product, but they would benefit from the heating or the cooling or the electricity or the lighting or everything that is provided to them over there. So basically they take the cheaper way. And upgrading appliances or the insulation was more common for the case of non-students because they own the household and are prepared to spend more for the house. But some of the also hidden parts that are not taken into consideration inside the national data is that some mentioned that they would simply just endure, and even though it's hard, even though it's cold or hot, they would just rather not turn on their heating or cooling device because it would be expensive by the end of the month, or they would adjust their codes in order to reduce this consumption, or they would replace the electricity with cheaper sources such as kerosene, which raises also um, the side of the climate change and emissions aspect. And between these two students and non-students, we also conducted a chi-square test and saw that the answers between two categories was also statistically significant. So in conclusion, back to the research questions, what is the condition of energy poverty in Japan? Well, it increased from 4.7% in 2004 to 8.4% in 2013, and there was a slight decrease from 2014, an increase expected again since 2016, and currently at 2019, or sorry, this should be 2020, estimated at 13.2%. And the type of households most vulnerable, well, the single couple elderly, the single parents with a child or children, or ages 65 above, followed by 20 to 30, and the three lowest income deciles. Basically, the lower the income becomes, the higher the poverty rate goes. And is the reconsideration of categories needed? Well, perhaps, because the results show high energy poverty rates for students in comparison to normal residents. And why do we call it the hidden risk? Well, because the characteristics of the consumer's actions are not well reflected on the national data and are not investigated, and therefore the underestimation and effective countermeasures will lead and might be worsened in this situation. So here is some work in progress. On my clock, I can see 20 minutes have passed, but I can't hear anything. So if we have some time, we'll come back to this in the discussion section. So this was my presentation, and here's the reference list. If you have any questions or suggestions, or you would like to discuss anything, I'm here and would be glad to do so. Thank you very much, and that is all from me.
Okay, thank you, Amin. So we have time for one question.
Sure.
Yeah, I would love to ask a question. First of all, thanks, Amin, for the great presentation. Then I have three minor questions, but I already saw that you addressed two of these points in your last slide. So my first question would be, I saw, if I remember it correctly, you conducted your survey up until December 2020.
Yeah.
So, and that was in the midst of the COVID-19 pandemic. So my question would be, what is the impact of that? Then I would be curious if the sample is representative of the student population in Japan. So maybe you did any checks on that. And my third question would be if you consider to use any other energy poverty indicators except the 10% indicator.
Hey, thank you very much, Benedict, for your questions. Sorry, I don't know which slide you're referring to for the.
Okay, I mean, try to be very quick in the answer,
sure.
the reply,
So,
because, and if I can add to Benedict's question, do you have any element which could help in understanding what is the housing condition of the students? Because at least for me, it is not clear if they live usually in student residential houses, or if they just go on the private market, and so they try to have the lowest, the lowest rent, and so they are living in the worst houses. I don't know, something like that, because I think that would be really relevant to understand that point. Thank you.
sure. Yes, so 4 questions. I'll try to answer them.
Yes, very quickly, because then we have to go to Enrico.
Yes, I would like to apologize to Benedict. Well, if you misunderstood or if I wrote somewhere wrong, it was basically up until December 2019 and January 2020.
Okay.
So we have another set coming for during the COVID. So that will be the work that we're doing right now. I couldn't catch your second question. As for the third question, the indicators, definitely we are thinking of doing so, because the 10%, as you also might know, is quite limited. And in order to catch the energy poverty inside a city or a country, we need to see what are the main indicators or main things that would impact energy poverty. So we are also considering to develop a new indicator in this case. So there would be a multi-criteria indicator. As for Paula's question, yeah, so the housing situation basically, as I understand from the European market, is quite hostels, or the dorms are quite how do you say, like they're really on high demand. But in Japan, also in this study, nearly all of the students are living in private houses. So this is the difference between the European studies, that most of the students are living either in hostels or in low-paying houses. But in Japan, basically, even if there are some kind of dorms provided by the university puts a limit of 1 year and asks you to seek private households, private dwellings or houses. So all the ones that were mentioned in this study were also the private houses in this case.
Okay.
And yes, the second question by Benedict, sorry, I couldn't catch the question, but if you have, I'll be really glad to discuss it with you.
Okay, so thank you very much, Amin, for the nice presentation and for all these replies. We move to Enrico. Please, Enrico, the floor is yours, 20 minutes. I will tell you 5 minutes before the end. Could you share your screen? Yes.
Yes, you should be seeing it. Right, so good morning, good afternoon, good evening, everyone. My name is Enrico Nano, and I am a fourth-year PhD candidate at the Graduate Institute in Geneva. And today I'm going to present you a paper on this topic I really care much about, on access to electricity in Nigeria. And I'm going to focus on the causal impact at the household level on education. So let's start with some motivation background. Here is a map of access to electricity in terms of people without access to electricity.
Enrico, we still see your first slide.
Oh, really?
Yes. Try to move up and down. No.
See this? Let me perhaps stop sharing and share again. Do you see this?
Yes, we can see.
Okay,
Sorry.
Great. Yes, so I was saying that Nigeria is one of the countries in the world with the largest number of people without access to electricity, and also one of the highest rates The access to electricity in Nigeria is very, very heterogeneous. There are 98, almost 100 million people lacking access as of 2018. As I said, the largest country worldwide after India, with an average electrification rate of about 45%, with, of course, a lower average rate in the rural areas compared to the urban areas. And as you can see in the map, it's also very different comparing in different regions. So around the coast, where the main cities are the capital, the access is much higher compared to the center, north, and eastern parts. And as you all know, also quality of the access to electricity is important. Taking the World Bank Enterprise Survey of 2014, which is the last one, more than 3/4 of firms experienced at least one power outage during the previous year, with an average number of blackouts of almost one per day, very long length, and a reported average loss on annual sales due to outages above 15%. But here we're going to focus on the household level. And in this chart, you see the distribution of the access to electricity across LGAs, which are the administrative units, the local government authorities, in terms of proportion of households having access to electricity. And you see there are two peaks here, so one around 0 and one around 1. This means that in this LGA, in this local government authority, no household had access to electricity. In this peak, all of them had. But of course, there are also many administrative units in between. How to get access to electricity? There are many ways, but in Nigeria, the main source is the national grid for more than 80% of the households, with the remaining households getting access from rural electrification programs such as mini grid and off-grid solutions, as well as autonomous solutions such as solar panels. But of course, the grid expansion is not random. It's driven by technical feasibility, it's driven by expansion costs, but also political reasons, corruption, and the expected returns on the supplier side. And another reason why access to electricity cannot be considered random is that even if the area is electrified, even if the grid arrives to a village, the actual access to electricity by a household, it has to be considered as an investment, because they have to pay a connection fee to be connected to the grid, or even if they go for an autonomous solution, solar panels or generators are to be considered as an investment in itself. And there is an additional issue, which I will consider, that even non-connected households in connected villages may still experience benefits from other households in the same village which are connected. So think about sharing of electricity between households, or even stealing of electricity, or also employment spillover. So if my neighbor has access to electricity and starts a little shop or another activity and employs someone from my household, I am benefiting from this other connected household. I will go very briefly over the existing evidence on the development impact of access to electricity in developing countries. As you see in this summary table, the evidence on welfare and consumption is quite high, with a high statistical significance. In a previous paper, I focused on labor market outcomes, employment, wages, and so on. And indeed, in line with the literature, we found positive effect, but with a lower level of significance and magnitude compared to the welfare results. While in this paper, in this presentation, I'm going to focus on education, and in particular on two measures of kids' education: school enrollment and school output. And we'll see that we kind of are in line with the literature results, with the previous literature results of positive effects with a medium to high level of statistical significance. I'm gonna skip all the literature review, and in this slide, I'm gonna basically summarize the paper in a nutshell. So as I said, I study what is the micro level impact of the access to electricity on kids' education in rural Nigeria. So to focus on the area where actually this issue is really binding. And I mentioned that I studied both the extensive margin, the school enrollment, and more intensive margin using the grade for age gaps, which is a measure basically saying how many years a kid is behind compared to his age. So if a kid is 6 years old, he should be in the first year of elementary school. If he's 8 years old, in the first year, he has a 2 years grade for age gap. And I measure outcomes at the household level and not at the individual level for two reasons, mainly because my panel data are at the household level, and also I can incorporate the intra-household dynamics for the decision in households with many kids. And I measure the access to electricity at the village level instead of the household level to incorporate those spillover effects that I was referring to before. And then I introduce a new instrument which has been used in the literature, but not for this type of studies on the micro level development impact of access to electricity, which is lightning strikes. So lightning strike intensity is measured in the area, of course, surrounding the household geolocation. Then I also quantify the effects of the quality of electricity received using a proxy, which is the frequency of blackouts, controlling for sample selection. I used panel regression methods, controlling for household and year fixed effects. And of course, I have several covariates, including demographics, other household level variables, and also geographic and meteorological variables. And in terms of findings, I find that access to electricity increases the proportion of kids enrolled at school by between 28 and 56%. Within the household, access to electricity also decreases the grade for age gap, so positive impact on school output by almost 3 years. And this estimated impact is larger if I focus on actually connected households. This is kind of obvious. But interestingly, I find larger point estimates for girls, but only when I split the sample, only significant for boys. I also find that the enrollment effects are larger for households that are poorer, only for enrollment effects, not for the grade for age gap. So at least on the extensive margin seems to be more of a pro-poor policy. And when I study quality of electricity using blackouts, I find a negative impact on the school output instead, so the grade for age gap, but not on enrollment. And finally, in terms of first stage, as you understood, I'm using an instrumental variable strategy. Both lightning intensity and higher distance from power plant, which are my two main instruments, negatively affect both the access and the quality of electricity. Here, in terms of conceptual framework, I'm mainly focusing on this part of this chart. So the impact that mainly lighting has on the allocation of time between labor and education for a kid between 5 and 15 years old, and then this will lead to eventually improve household welfare. The data that I use is the World Bank LSMS, which is a general household survey in Nigeria. It is a panel of 5,000 households between 2011 and 2015, and I focus on the 3,300 rural households. It is a representative data set with a very low attrition rate. And the main instrument that I use, which are the lightning strikes data, is coming from this NASA's data set and the actual measure that I use is the average monthly number of lightning events in an area of 30-kilometer radius around the household geolocation. Over a period of it's an average over a period of 2 years before the survey, in order to smooth as much as possible potential idiosyncratic effects on specific years. And as you can see from this table, access to electricity is very heterogeneous. It has an average of about 46%, more or less in line with the data that I showed you before, but with a very high standard deviation. And this at the village level. If I focus on the household level, it's even lower. Of course, it's 36%. And yeah, I'm gonna go a little bit quicker to this in order to move.
Enrico, 5 minutes to go.
Okay. I see I have 8, but
okay, go for 8. Go for 8,
okay.
And then we will have a very short question. Okay, go for it.
All right. Yeah, here just to show you the distribution of the lightning strikes, both geographically and across the timeline. And here are the 2 main outcome variables that are studied. Mm-hmm. If I look at this from a purely descriptive perspective, separating my sample between non-connected villages and connected villages, of course, I see an increase in proportion of kids enrolled at school and an increase in the proportion of kids with a very low or 0 grade 4 age gap. But of course, we need to model this empirically. So if I were to use a naive random effect model, I would regress the enrollment or grade 4 age gap at the household level in I in year T, with access to electricity being a dummy 0-1 and controlling for this set of demographics and household and meteorological covariates. But of course, I also include household and year fixed effect, and in basically all regressions, I find that this is the suggested model against the random effect one. But as I mentioned at the beginning, I also need to consider endogeneity issues, because access to electricity is not random for both omitted variable and reverse causality issues. Because as I mentioned, the extension of the grid and the household decision to connect may depend in turn on the outcome variable. So I use a instrumental variable strategy, which has been widely used in the literature with several approaches. Here, I'm just mentioning the one that I could use with the data that I have. But all of this would have some issues in terms either of exogeneity or relevance. And while using lightning strikes solves both these issues, and it's also quite innovative compared to the previous studies. So let's go quickly to the result. Here you see only the variable, the independent variable that is relevant for the study, so the access to electricity at the village level, subsequently increasing the level of covariates, as you see. And the outcome variable is the proportion of kids enrolled at school. And you see that the impact is quite positive throughout all the regressions, with a stronger negative first stage. The last 2 columns, there is a drop in the magnitude of the coefficient, while the statistical significance remains the same, because here I basically add the average education at the household level, but it also leads to a drop in the sample. So this is actually a sample issue, and this is why I report the increase in enrollment as something in between 28 and 56%. So positive impact on school enrollment and negative impact on the grade 4 age gap. So positive on school output overall. And here the measure is quite more stable, the estimated coefficient, increasing from using demographics, the other household level covariates, including wealth, measure the meteorological covariates and the household level education. It doesn't lead to a drop in the sample, and the estimated impact is quite consistent across the specifications. And the estimated impact is indeed of a decrease in the grade for age gap of 2.8 years. Then here there are a number of robustness checks. I will go very quickly over them. Here I basically compare the results that you already saw for column 4 and 5 for the village access to electricity to the household level 1. And as you see, of course, the estimated impact is still significant, but higher in terms of magnitude, because here we are focusing on the houses that are actually receiving electricity, while here there are also some of them that are in a connected village, might be enjoying some spillovers, but might not have access themselves. Here I vary the radius over which I consider the lighting intensity instrument, just to show that results are still consistent. And also to kind of further prove the exogeneity of my instrument, I add an additional instrument, and yeah, here I basically focus on this test, the Sargan-Hanses test, which is never significant, showing that there are no exogeneity issues. Here I split the sample by gender, which I mentioned at the beginning. We find significant results only for boys, but with a larger point estimate for girls. This could be due to the fact that boys are required to work in many cases. There's a lot of child labor in Nigeria, but thanks to lighting, thanks to access to electricity, they could also study during the dark hours in the evening. And if I run some more heterogeneous regression by wealth, you see that only this coefficient is significant when I interact the connection at the village level with the wealth variable, showing that increasing wealth leads to a decrease in the proportion of enrollment. So the largest impact is actually for the poorer households on enrollment, while for the school output measure, there is no significant heterogeneous effects. And final results is about the quality of electricity. So here I'm using this measure of blackouts. So the higher this index, basically the more frequent blackouts are experienced. But of course, to measure the impact of blackouts on enrollment and the grade for age gap, I am limiting the sample to only those households that are connected, of course, to experience any blackout. So there is a sample selection issue, which I solve by using a Heckman regression model. Here I use again the other instrument, the distance from the nearest power plant, to control for sample selection. And what I find is basically that there is an impact of blackouts on the quality of schooling, on the output of schooling, which is also intuitive, because if you have a lower quality of electricity, the actual use that you do of lighting and electricity is less effective. So blackouts are impacting more on the output side than on the enrollment side. And this I'm gonna skip. And yeah, I'll leave it to the conclusions. Electricity is indeed a big concern in developing countries like Nigeria, and having access does make a difference for kids' education, even in the short to medium term. As I said at the beginning, I have only 4 years span between the 3 waves of the survey. And even after controlling for time invariant specific effects, endogeneity issues, I find a large impact on both school enrollment and school output. The effects are larger for girls, but only significant for boys, and that the results are robust to varying a number of things. I also find presence of spillover effects with a different coefficient magnitude between household and village access to electricity, and that it does favor everybody, but it seems to be more of a pro-poor policy along the wealth axis, in particular for enrollment. And finally, that the quality of electricity doesn't play a role on school enrollment, but it does on school output. Thank you very much.
Thank you, Enrico. Thank you very much for your presentation. And I just have a very quick question, if I may. You explained at the very beginning that the access to electricity in Nigeria is not random. So these investments are, let's say, driven by several elements. My point is, all these very interesting results about education, could it be that they are driven by other elements? So I understood that you use fixed effect. So somehow you try to address this point, but it could be that in a place where, you know, electricity has arrived, it is also that there are other elements that somehow have an impact on education in the way in which you capture it. So my point is that it could be that I'm not sure that it is only electricity, the effect you find.
Right. So there are at least 3 or 4 ways that I try to address this issue. So one, as you mentioned, I used fixed effects. So I'm only considering the within variation over time. Mm-hmm. Then I control for the wealth of the household. Mm-hmm. So this is one of the main issues usually, but also distance to the nearest market, distance to the nearest population center. So if these households are remote households, I am already controlling for this. And then of course, the main identification strategy related to endogeneity is the mm-hmm. fact that I am instrumenting my access to electricity with lightning strikes. So something that is very exogenous to the outcome variables. Okay. In a previous version of this paper, I was using the solar radiation intensity, but it was more potentially connected to agricultural output, while lightnings should not affect controlling, of course, for precipitation, temperature, and wetness, the agricultural output, which may in turn affect the access to electricity. And finally, I am also to also check if this is a valid identification strategy. I went a bit quick on this. Mm-hmm. I ran this robustness check with 2 instruments. So I control for, so I instrument the access to electricity with both lightnings and distance to the nearest power plant, okay. which is something that should not be related to the access to electricity of the household itself, because a power plant could be many, many kilometers away, still to be connected to the grid. That's where the issue lies.
Okay. Yeah. Okay. Thank you. Yeah. Thank you very much for the nice reply. So I propose to move directly to Benedikt if there aren't a very quick question to Enrico. Other question to Enrico? Maybe we can be back on Enrico's presentation at the very end of the session. And
or if you want to address any question, you can write me on the email that you find on the
Fantastic. Very good, Enrico. Thank you. Benedikt, the floor is yours. 20 minutes, please.
Yes.
And then we will have Pooja.
Do you see my screen?
Yes.
Okay. Where's the full screen there? So, yeah, thanks for having me today. I'm Benedikt Janzen. I'm currently a PhD student at the University of Bern. And I'm going to present the paper Determinants, Persistence, and Dynamics of Energy Poverty, an empirical assessment using German household survey data. This is joint work with Katharina Drescher, who's currently a PhD student at the University of Passau in Germany. So what is energy poverty? We heard it in our previous presentations already. So it has something to do with experiencing an inadequate level of domestic energy services. It is somehow related to energy inefficient homes, high energy costs, and of course, low household income in general. But there's currently no uniform definition of energy poverty in Germany. So it's not officially recognized in Germany. However, during the last years, there has been a lot of effort on the European level, and the Energy Poverty Observatory there are four primary indicators to capture energy poverty in the EU, which are arrears on utility bills, low absolute energy expenditures of a household, high share of energy expenditure and income, and an inability to keep the house adequately warm. So these are the four primary indicators in the EU, but there are also a lot of secondary indicators that play also a role in the recognition of energy poverty in the EU. So why is it a concern in general? So there's a lot of research on the negative welfare effects of energy poverty, such as a reduction of mental and physical health, a reduction of children's educational attainment, and it has also an influence on personal well-being, etc. So that's why it is a concern. Also, in the light of a just and fair energy transition, it's a concern. So because in Germany, there are rising energy prices due to cost pass-throughs to households. That's why one has to take care of lower income households when talking about the energy transition in Germany. And that's why it's also a concern to address. So there's also quite some literature on energy poverty. Basically, most of it started in the UK with Boardman in 1991. And especially in the UK and in Ireland, there is already a broad literature body on that topic. But also in the recent years, there's a growing number of studies on the prevalence in other European countries like Spain, Italy, and also other non-European developed countries, like we heard in our first session, for example, in Japan or in the US. However, most of these studies focus on the extent of energy poverty, and empirical findings on determinants compared to the literature on the extent of energy poverty are rather limited. For example, one of the main examples is a paper by Healy and Clinch in 2004, and they find that long-term ill and lone parent families are among the most energy vulnerable households. In Germany, there's only one other paper that considers determinants of energy poverty, which is by Heimdall and Schüssler, and they find that income, employment status, and housing conditions are most important in energy poverty. Then most of the studies only consider the static context, so they use cross-sectional data, mostly due to a lack of suitable panel data. There are only few other studies that are in a dynamic context. One of them is in Spain by Finister et al. From 2015. They look at movement out of expenditure-based energy poverty and income poverty. And another paper by Chaton and Lacroix from 2018. They look at energy poverty transition in France. So the data we use in our analysis are data from the German Socioeconomic Panel, which is the representative panel study in Germany. It started in the 1980s, and the last wave is from 2019, so relatively recent data. And it has a lot of information on socioeconomic, socio-demographic characteristics, as well as housing conditions and household preferences, for example. We use 8 waves from 2013 to 2019. And all in all, we then obtain a balanced panel of 6,260 households, which leads to a sample size of 34,000 households in total. So we're going to use different measures of energy poverty in our study, and two different approaches. The first approach we consider is the expenditure-based approach. There are three indicators that we consider. One of them is the 2M indicator, which is also one of the favorite indicators of the Energy Poverty Observatory in the European Union. And it basically says that if the share of income spent on energy is more than twice the national median share, then a household is considered as being energy poor. Then we use the 10% rule, which says if the share of income spent on energy exceeds 10%, then a household is energy poor. That is basically the indicator that we saw in the first presentation today. And we use the third indicator, which is standard in the UK, and it considers energy expenditures and income, and it says if an household is pushed below the poverty line after energy expenditures, it is considered as energy poor. So these are the expenditure-based approaches to energy poverty. Another approach would be consensual-based. It's based on self-reported poverty. So if a household self-reports an inability to heat its home due to financial reason, it is considered as energy poor. So these are the four indicators that we consider, two of which, the 2M and the 1 indicator, are official European indicators. So we first look a lot of the descriptives. So this is the PDF of equivalized monthly electricity, heating, and energy expenditures in Germany, based on our pooled sample of 43,000 households. So the median is 110 euros, and the mean expenditures on energy are 120 euros per month. We equivalize all of our income and spendings by household size to make it more comparable. And then we look at the average share of monthly energy expenditures and income, and the average share is 7.6% per month in Germany. We divide our sample in income deciles to check the prevalence of energy poverty in different income deciles, and we see that energy expenditures increase with increasing income. So the more a household earns, the more he spends on energy, and the lower the share he spends on energy is. But we also see that the energy use intensity, which is basically energy expenditures per square meter, decreases with higher income deciles. And this indicates some level of inefficiencies in the lower income deciles. This may be due to inefficient housing, or even due to inefficient energy use of the lower income deciles. We check the energy poverty rates in per income decile. We see that most of the energy poverty burden is beared by low income households. We have actually an energy poverty rate of 75% in the lowest income decile, and it decreases the higher we move on the income ladder, basically. In our pooled sample, we have the prevalence of energy poverty in Germany is, depending on the indicator, between 8 and 21%. However, if we look at the consensual-based energy poverty, only 1.67% of households in Germany report an inability to keep their home warm due to financial reasons. We see that also some households in the upper income deciles report an inability to keep the home adequately warm. We believe that this is because some households might misinterpret the question and maybe state that they don't heat their home due to savings motive, and not because they can't afford it, of course. We check the overlap between our indicators, where this line is the energy poverty line. All households above this line are considered energy poor under our expenditure-based energy poverty. indicator. This is the 2M indicator, and every triangle shape is one household that reports an inability to keep their home warm. So we see that not all households that report an inability to keep their home warm are also poor under the expenditure-based indicators. So it also captures households that are not poor under an expenditure-based indicator. We then go on. Our empirical strategy is basically twofold. We first use a dynamic random effects profit model to identify persistence and driving factors of energy poverty. And then we use an identification function and multinomial logic model to differ between different energy poverty states, to differ between chronic poor energy households, chronic energy poor households, so households that always experience energy poverty, and households that only sometimes experience energy poverty in Germany. So this is our dynamic random effects profit model. This is the latent version of our model, where we include our lag dependent variable. This is basically our independent variable of interest. So if this gamma coefficient is 0, there is no state dependence in energy poverty, which means that the experience of energy poverty in the last period does not affect the experience of energy poverty in the current period. We also include a lot of covariates, such as education, labor force status, housing conditions, and heating system in place. We introduce some heterogeneity into our model by including this term, the UI. This is a household level heterogeneity. But in general, there's a problem with these types of model because there's the initial conditions problem. Since we do not observe the stochastic process right from the beginning, our estimate of state dependence will probably be biased. So there have been two main approaches in the literature to address this problem. One was proposed by Heckman, who says that we can model the initial stage jointly with our whole model, and the other solution that was proposed by Wooldridge basically says that we model our individual heterogeneity term, conditional on the energy poverty status of a household at the beginning of our panel. So that is how we can address our initial conditions problem. So we model the individual level heterogeneity by including the within means of all our exogenous covariates, as well as the values of our covariates at the first observed period. And if we plug this into our model, then we get our full model, where our gamma coefficient should be an unbiased estimate of energy poverty persistence. The second step is an identification function, which looks more complicated than it is. It basically just labels households that spend more than 70% of all observed periods in energy poverty as chronic energy poor. All households that do not experience energy poverty at all are considered as never energy poor, and all households that sometimes experience energy poverty are labeled as transient energy poor. We then use a multinomial logic model to work out the differences between our never energy poor households and our transient and chronic energy poor households, where we use our never energy poor households as a reference group. But this is still work in progress, so we're still revising that section. So these are the results of our dynamic random effects profit model, where
5 minutes, Benedikt, 5 minutes.
Where this REP is the naive version of our model, where we do not control for the initial condition. So we see the coefficient is large in magnitude and highly significant. If we control for the initial condition of our households, we see that the coefficient decreases, but we still find large and significant state dependence in energy poverty. regardless of the expenditure-based indicator, if we look at consensual-based energy poverty, we do not find any state dependence. So this basically means that a household that experienced energy poverty in the last period is 3.8% more likely to experience energy poverty in the following period as well. We included a lot of covariates. As said before, we find that household composition, education, and labor force status are important factors. Single parents and families living, people living alone are the most people at risk of energy poverty. We find that relative to being employed, non-working households are 3.4% more likely to experience energy poverty. We found that energy efficiency measures significantly influence the probability of facing energy poverty, such as thermal insulation or living in a newly built housing. All these factors significantly influence the probability of facing energy poverty. We also included the primary energy source of the households, and we find that oil and electricity as primary energy source instead of gas significantly increase these chances of facing energy poverty in Germany. As said before, our identification function, these are the results of our identification function. We find that most of our households are never experience energy poverty at all, and only 6.1 or 4.5% are chronically energy poor in Germany. So we conclude that most of the energy poverty in Germany is actually transient, so households do not experience energy poverty persistently. If we look at the table above, we see that like we have 7 years in total, and only 1.2, 1.9 or 5%, 5.7% of households are energy poor in all 7 consecutive years. We then did our multi-nominal logit. However, this is still work in progress, and we're still revising this section, but it all the covariates have the expected sign, so we find similar results to the results of our dynamic random effects probit model. So I'm not much about this. Conclusion. I will just quickly finish my conclusion. Understanding household level determinants is crucial for policymaking because policy implications might differ for transient and chronic energy poverty. We find significant evidence of state dependence in energy poverty, but all in all, it's mostly a transitory state in Germany.
Okay. Thanks.
All right. Thank you.
Thank you very much, Benedikt, for your nice presentation as well. So there is already a question on the chat by Yuxian Ye. Sorry for my wrong pronunciation eventually. So one minor comment, how do you equivalize energy expenditure and income?
We do equivalize energy expenditure and income by the square root scale of the OECD. So we divide it by the square root of the household size.
Okay. Other questions? If not, I have a not really a very quick question. It is about this transient energy poverty. Okay, it was not really clear to me how you define it, but consider that in the literature, in recent literature, there are quite a lot of papers. I can give you references about the risk of being in energy poverty, which is somehow close to your transient energy poverty, because it seems to me that this transient energy poverty could be not really easy to be identified, while the risk to be in energy poverty, it is maybe a better way to approach the issue. Because consider, for instance, if the energy poverty comes from the high cost from housing, okay? So this kind of energy poverty will change only if you have new efficiency in the house or if you move to another house. If energy poverty comes from low income, again. So with this transient energy poverty, you really do not address what is the drive of the energy poverty. Maybe it's better to be in this approach on the risk of being energy poverty, or in any case, it would be nice to consider that.
All right, thanks. It would be great if you could send me the papers you're referring to.
Sure.
All right, thanks.
Other questions? So if not, we can move directly to the last paper. So thank you very much again to Benedikt. The last paper is by Pooja. Pooja is here. I can see Pooja connected, but not.
So the last paper is by me.
Yes. Could you open your camera and share your screen with the presentation?
Yes.
Okay.
Sure.
Good. Okay, Pooja, you do have 20 minutes and the last 5 or 4 questions. Okay.
Yeah.
Okay. Now we can see your screen. Okay.
Okay, so hello everyone. My name is Pooja Sankhyayan and I'm from School of Humanities and Social Sciences from the Indian Institute of Technology, IIT Mandi. So the topic of my presentation today is energy consumption behavior of Indian households and application of LAEIDS. So following is going to be the scheme of my presentation. First, I'm going to talk about the motivation of this study. From there, I'm going to move on to the research objectives that I'm trying to address in this study, the analytical framework that has been developed to look into these research objectives. Then I'm going to discuss the results of the study and then state the key findings of the study. So to begin with, the 7th Sustainable Development Goal as given by UNDP has emphasized on ensuring access to affordable, reliable, sustainable and modern energy for all. Likewise, IAEA, International Energy Agency, has also defined energy access in terms of a household having reliable and affordable access to both clean cooking facilities and to electricity. An agency in India called the Niti Aayog defines access to energy in terms of overall well-being of people, whereby it says that access to energy enables people to augment their income and also improve their productivity, which in turn will provide them access to healthcare, water, sanitation, and other civic amenities, which is going to improve their overall well-being. So if you look at the figures in India, still 56% of the households, they are making use of traditional fuels for the purpose of cooking, and 5% of the households do not have access to electricity, meaning thereby that India still has a significant population which lacks access to clean fuels. So if you look at various government initiatives that have been undertaken, so the policy framework finds that the solutions they've tried to provide solutions in terms of subsidizing the use of these two clean fuels and removal of first cost barrier. So when I talk about removal of first cost barrier, that is done by way of providing free LPG connections or by way of providing free electricity meters in the households in order to increase the access to clean fuels. So although there have been so many initiatives by the government, but the transition from traditional to modern fuel has still been slow, which has further resulted in health and environmental consequences, to the extent that we found that household burning of biomass was alone responsible for 24% of outdoor particulate matter 2.5 concentration in the year 2015. And other than that, there was a high mortality burden due to household air pollution to the extent of 0.48 million alone in the year 2017. So we find that the use of traditional fuels not only has negative consequences, rather on the other hand, household access to clean and modern fuels is found to be positively correlated with Human Development Index. So if you look at these two graphs below, The left-hand side graph here shows the percentage of household using LPG as primary source of cooking against State Human Development Index. And the right-hand side graph shows here percentage of household using electricity as primary source of lighting against State Human Development Index. And both of them are shown to be positively correlated. So the research objective that I'm trying to address in this study are identifying whether there is any sign of energy transition in terms of energy ladder or energy stacking hypothesis. And secondly, I'm trying to estimate the behavioral parameters of household with respect to energy demand for both energy and non-energy commodities. And for the same purpose, the data set that I'm using is from the National Sample Survey. This is called the 68 Consumer Expenditure Round. The survey was conducted in the year 2011-12. So as you can see below, these are the various categories mentioned for which the survey was conducted. The total number of households surveyed in this particular survey was 1,01,651, and given the rural and urban households within the survey areas. So this is the descriptive statistics for the variables for different at the national, rural, and urban areas. So at the national level, we see that the monthly per capita expenditure is around 2,262, which goes down to 818 in the rural areas and is 2,894 in the urban areas. Then out of this monthly per capita expenditure, what is the share of the food? So if you look at the national level, you find that the share of food is 54% at the national level. It goes to 57% in the rural areas and is 50% in the urban areas. As far as the share of expenditure in the monthly per capita expenditure is concerned, it's more or less the same across these three levels. So 8% at national level, 8% again at rural level, and 7% in the urban areas. Now, if you look at the composition of this energy expenditure, we find that there are three categories which have a high expenditure. So if you see here, the share of expenditure is 29% for firewood and chips, it is 22% for LPG and 30% for electricity. Now, this expenditure on firewood and chips goes to 40% in the rural areas, whereas the expenditure on LPG falls to 14% in the rural areas. But in the urban areas, we find that the highest expenditure is on electricity, followed by LPG here. So these are the expenditure share of different sources of fuel for cooking and lighting at different levels. So this bar here shows at the national level, rural areas and urban areas. The right-hand side bar graph here shows the expenditure profile of households, both in the rural and the urban income quartiles. So here you can see that the green section of the bar shows the use of firewood and chips in the rural areas, which is higher as compared to the urban areas. Whereas if you look at the use of LPG and electricity, this is higher in the urban areas as compared to the rural areas. Now, looking at the energy expenditure profile of households, so rural income quartile 1 here shows the 25% of households having the lowest income, and quartile 4 here shows the 25% of the households having the highest income, both in the rural and the urban areas. So through this bar graph, I'm going to talk about the energy transition in terms of energy stacking and energy ladder behavior. So if you look at the energy ladder hypothesis, the energy ladder hypothesis it tells us about the household fuel use in developing countries. It states that as the income of the household increases, the household it shifts from the use of traditional fuels such as biomass first towards the use of an intermediate fuel such as kerosene, and ultimately to make use of modern fuels. Whereas energy stacking hypothesis it corresponds to multiple fuel use behavior of the household, whereby household will make use of different fuels from lower and upper levels of the energy ladder. So if you look at this graphs here you will see that there is a shift in the use of different fuels in the household. So in the rural households, you find that the use of firewood is going down, whereas the use of electricity and LPG is going up, both in the rural and the urban areas. Whereas in the urban areas, if you see, the use of modern fuels is more pronounced, and there's a high decline in the use of firewood. So if we look at it in terms of the energy transition behavior, so here we see that it is not the energy ladder, rather it is the energy stacking behavior which is more prominent, whereby we see that the people are not completely abandoning the use of traditional fuel, rather there is a simultaneous use of fuels which is taking place. Also, one important thing that this bar diagram indicates is if you look at the energy expenditure profile of rural income quartile 4 and urban income quartile 1, you will see that the use of fuels is similar in these two income profiles. So meaning thereby that if a household with the same income that is situated in the urban areas is likely to spend higher on energy. So now addressing the second research question, whereby I'm trying to estimate the behavioral parameters of household with respect to energy demand for both energy and non-energy commodities. So for the same purpose, the analytical framework makes use of linear approximation of almost ideal demand system, whereby we are trying to estimate the expenditure shares by making use of Shor model, that is the seemingly unrelated regression equation model, given the assumption of contemporaneous error terms, that is the error terms, they are related in one point of time. So here in this equation, WK is the expenditure share of category K, alpha K is the constant, gamma Kj and beta K, they are the parameters. Gamma Kj here represents the change in the relative price, that is what is going to be the effect on the change in the expenditure share of K when there is a change in the price of J. So beta K here represents change in real expenditure. X by P is the real expenditure, where X is the total expenditure and P is the price index. Now these parameters, they are used to estimate the own and cross price elasticity values. They are estimated given as EKJ is equal to minus delta Kj plus gamma Kj minus beta K by WK. So gamma Kj here is the Kronecker delta, which is a function of two variables, which is equal to 1 for own price elasticity values and equal to 0 for cross price elasticity values. So also I'm estimating the expenditure elasticity here given as EK is equal to 1 plus beta K by WK. So if we look at the literature, so likewise studies have been conducted in different countries, given here Zimbabwe, Kenya, Pakistan, China. So the similar study was also conducted by Gundimeda and Pohlin in the year 2018. They made use of the data set from 1999 using the same methodology. But we see here that all of these studies, they are including fuel wood in the calculation of price and income elasticity values. Whereas the understanding is that fuel wood is non-marketed. So how is it going to affect the modeling of the data? So that is what we are trying to address in this particular study. So if you see here, I'm trying to estimate two models. This is called the overall model, whereby I'm estimating expenditure share of food items, energy, and clothing, bedding, footwear as one category. And model 2, which is the energy sub-model, I'm estimating for three categories of fuels, marketed categories of fuel, kerosene, electricity, and LPG. Also, during the modeling, we try to model using different categories. So here you can see I try to include firewood and chips in different models, but the results suggest that model 2.4, which included 3 categories, was a better fit as compared to the other models. So these are the results that I have obtained. So here you see that these are the own price elasticity values. So this is for the energy category on the overall model. So the first result here suggests that energy demand, this is sensitive, this is price sensitive, and it is more so for people living in the lower income quartile. So here if you see, the value declines from rural income quartile 1 towards rural income quartile 4, and likewise in the urban areas. That means that if the price of a modern fuel goes up, that is not going to affect the consumption of the households in the higher income quartiles, whereas it is going to adversely affect the uptake in the poorer households. So looking at these numbers, we can say that we can look at a cross subsidization model, whereby the subsidy given to the richer households can be withdrawn, and that can be given to the poorer households in order to increase their uptake. Also, if you look at the policy framework already addresses the price sensitive nature of these fuels by subsidizing the use of LPG, which is under the DBTL scheme, that is direct benefit transfer scheme for LPG, and the state governments are subsidizing the use of electricity. And also, I talked about earlier, they are also addressing the first cost barrier, that is providing free connections both for electricity and LPG. The other things that this through the energy submodel, the result suggests that the kerosene is a given good given the positive own price elasticity in the rural and these income quartiles. So this is the implication for the use of electricity, whereby electricity is found to be a better substitute to kerosene, and the use of electricity can go up given the cross price elasticity values. Also, if you look at these figures, you will find that the demand for LPG is more price responsive than demand for electricity in these results. So these are the expenditure elasticity again at different levels. So here also you see that in the overall model, the energy, it has high expenditure elasticity value. That means if the income of the consumer will go up, and thereby it will also affect the demand of these consumer towards the consumption of modern fuels. That is to say that the intervention can be made through the channel of income generation. So if again looking at the policy framework, we find that so this income is addressed partially and indirectly. If you look at the energy policies in India, that is by removing the first cost barrier. So if you remove the obligation on the part of consumer to spend a lump sum amount just to begin the use of modern fuel, if that barrier is taken away, the consumer has only to pay for the use of that modern fuel. So, but as I mentioned, this is an indirect approach. Rather, a more direct approach could be a push towards the increase in income opportunities of people. The same is done by one of the schemes, which is called MG Narega. But we need more schemes like this in order to push for the income generation opportunities for people to enhance the use of energy. So also the other results in the energy submodel suggest that the energy is found to be inferior good given the negative or expenditure elasticity value in these categories. Also, like the results in the price elasticity, here also we find that LPG demand is more sensitive to income change than electricity, given these figures here. So finally, the key findings of this work, whereby, as I talked about earlier, the subsidy can be withdrawn from the rich and given to poor. So this policy of cross-subsidization can actually benefit the poor and increase the uptake, especially in the poorer households. The other thing is that we can go in for increase in income, as we found that the responsiveness to income change towards the use of cleaner fuels is higher as compared to prices. As for the policy implication of this study, we find that we can make a suggestion for a shift in the policies for the promotion of clean fuels. That is by addressing the income barrier in order to enhance the uptake of modern fuels. So this policy recommendation, it can happen through the creation of employment opportunities and increase in rural livelihood in order to help in the generation of more income. So lastly, we know that the development is a multi-dimensional concept, and energy only forms a part of it. So thereby, the uptake of clean fuels, it cannot be treated as a standalone issue. Rather, it should be addressed along with the goals of housing, education, health, and employment in order to ensure the overall well-being of people. Yeah, so these are the references that I used in my study.
Okay.
Yeah.
Okay. So thank you very much for your nice presentation, and I open to questions. So any question, Pooja? Pooja? Sorry for my wrong pronunciation. Sorry.
Yes.
Okay, so I start with a very direct question. It seems from your result that there are, as one can expect, a very different finding for rural and urban areas. From your analysis, could you suggest policies addressing issues in the two different contexts, or do you think you should have a further investigation? Because this is something that I didn't got from your presentation. If the different result could also lead to the design of different policies, or you still have to do something to go in this direction?
Yes, so thank you for your question. So what we have done is, as a next step to this study, based on secondary data, we have also conducted a primary survey. So we are still looking at those results and trying to find out which can be the other important determinant as to the uptake of clean, as far as the uptake of clean fuels is concerned. Also, looking at the results, so they are different for the rural and urban areas. Yes, I agree to that. So here, what we see is so the hypothesis with respect to the energy transition behavior. So we can so there is a lot of energy stacking behavior which is visible, which again requires a different policy initiative. But the overall picture that emerged was, as compared to the last study, as I mentioned in the literature, that it is more income sensitive now, and there is a lot of interconnection between different goals which needs to be pushed, and you cannot just singularly push for the use of energy. Rather, it is all goals that you have to look into and give a push to all of them.
Okay, thank you. Other question or curiosity? Okay, if we do not have other question on the last presentation, so thank you very much again to the presenters. So we can open the floor to some sort of discussion or other question to the previous papers and presentation. In the meanwhile, there is a question by Yuxian Ye to the last presenter. How do you equilibrize energy expenditure and income?
So here we are looking at yes, so here expenditure. So because of the dearth in the data, we have taken the MPCE value as a proxy for income.
Mm-hmm. Okay, the question seems to be to all the presenters. So also Benedikt, Enrico, and the first presenter, if they do have Amin. So if they have a reply to this question in the chat, please.
I'm not too sure if I didn't answer that one before. I guess I did already. So
okay, so maybe Enrico and Amin could reply. Amin, Enrico, are you there? Okay, maybe they are not at the computer. Amin is here. Okay, Amin, please.
I think the question was directed at Benedikt during the Benedikt's presentation, so it wasn't inside mine or Enrico's presentation.
Okay, in any case, if you have to add something to this question or some reply, obviously you're more than welcome.
Right, so the energy expenditure and also the income, I think mentioned during the presentation, well, I think I don't quite get the question itself, but yeah, as we mentioned, we adopted the 10% indicator, which both were the data we collected were both in the same terms, so that is how we use them inside the indicator itself.
Mm-hmm. Okay, so the reply by Amin is that following the 10% indicator, you have just the expenditure in energy as a part of the income. So that is the way to connect both the information. Other questions or comments on? What it is, let me just add, since I work on this topic since 2006, when it was not an issue, even not an issue. it seems that all these different measures for energy poverty, they really predict completely different pictures. So we should, working on this topic, we should be very careful in using these measures. And I would suggest to use if not more than one, to use the one which is addressing in the best way that setting, okay? So since energy poverty is really a multidimensional issue, you have to look at what are the relevant elements of what you are investigating. So for instance, in Amin's case, I asked about the housing condition of students because it seems that that could be really a driver of the analysis, and that should be a way to, that should be addressed really carefully, okay? In Italy, for instance, as well, students, they go for private houses, and usually they try to have the lowest rent. So they used to live in not efficient houses, okay? For instance, if you go for an investigation about old people, usually we have in Italy, which is the setting I know the best, we have that old people, they live usually in very large houses. So we found through empirical investigation that there is this correlation about the age of the group we are investigating, in this case, the old, and the size of the house. So in this way, this kind of finding would be very relevant in terms of policy, because, for instance, you can say that a way to reduce energy poverty for the elder is just to help them to move to a smaller house, or to have energy efficiency in the house such that they close part of the house, okay? Or you can obviously think about other kind of solutions. And do you have any further comments or question?
Yes, I would like to actually add by your comment. It was actually quite accurate. For example, in our case, it was quite difficult to adopt any other indicators, whether it is the 2Ms or the LIHCs, because especially if you're looking at the smaller sample of data, for example, in our case, the college students level, you don't have that much data to refer to, or basically see where the mean or the average you can find within the national data and to compare to. So to begin with, there is no data stating anything about college students in Japan. So in the best case that we could actually see was the 10% indicator to find some kind of a representative of what the condition is, but not necessarily the best case. And yeah, also, as you also mentioned about the large houses and the lack of, for example, some standards in some houses, we also see that it's quite important in this case, because most of the households living in energy poverty in Japan have been found to live in houses which were built before 1970s. And that is when there was no standards for the insulation of the house.
Sure.
So the more insulation standards came into power, and it was updated every 10 years in Japan, you see a drop inside the energy poverty inside the houses. So that is a very accurate comment by you.
Okay, thank you, Amin. But also the part by Enrico on electricity in Nigeria and let's say in developing countries, I think it is really a relevant issue, because obviously more related to the access to energy. So we should investigate with very different tools, but it is really a very, very interesting topic. So I think it is time to close. So thank you everyone for being in this session. It was very interesting for me. And so thank you again for your nice presentation. Hope there will be soon other opportunities to meet and discuss about this relevant topic. So keep in touch and have a nice day.